Hello, everyone. Welcome to this session. I hope you are enjoying StrimziCon this year. So as you probably know, sorry, let me introduce myself first. My name is Gantigmaa Selenge. I go by Tina as well. I'm a software engineer at Red Hat and a Strimzi contributor. So as you probably know, the Zookeeper is officially removed from Kafka version 4.0, and hopefully this session will provide what you need to know when it comes to running Kafka cluster in KRaft mode with Strimzi. So we're going to start with some introduction to KRaft and how it compares with Zookeeper-based clusters. So don't worry if you're not familiar with it yet. And we'll then look at some metrics that are specific to KRaft clusters and useful to monitor. And then we'll see how Strimzi executes rolling updates for KRaft clusters, so that you know what to expect during rolling updates. And finally, we'll cover how you can migrate your existing Zookeeper clusters to KRaft. Right, so what is KRaft? So previously, Kafka used Zookeeper to manage metadata of the clusters. So Zookeeper is removed now, so you don't need to manage that separate Zookeeper cluster anymore. It's been replaced by Kafka's own implementation to store and manage metadata directly in Kafka. And this simplifies the deployment and management because you have fewer moving parts and a single system to manage. So things like authentication, configuration, protocol, and networking become simpler. And also you don't need to worry about that extra security layer between Kafka and Zookeeper. It also makes the cluster more scalable, taking the advantage of Kafka's own ability to scale, because Zookeeper cluster tends to have limit when it comes to scaling. And it makes the cluster more efficient because you get faster startup time, because you don't need to sync the metadata between Zookeeper and KRaft cluster. And also you get better performance because the metadata is stored in Kafka, stored directly in Kafka, so the updates to the metadata is much quicker. Right, so this is how Zookeeper-based cluster looks like. You have Zookeeper cluster that stores the metadata, and you have your Kafka clusters with broker nodes. And one of the brokers is designated as a controller, and that handles the partition assignments and coordinates the metadata update with Zookeeper and other brokers. And this is how KRaft cluster looks like. Now you just have a Kafka cluster with some nodes serving as controllers and some serving as brokers. And one of the controller node is designated as the active controller, but I'll explain more about that in the next slide. So controller nodes forms a quorum, and it uses the Raft consensus protocol, which is more efficient compared to Zookeeper because it has quicker failover and recovery. So it's essentially a distributed metadata quorum where each controller node is storing metadata topic locally. And this topic is called cluster metadata. It's an internal topic. And with the Raft consensus protocol, one of the nodes is the quorum leader, and this is called active controller. So I might refer to it as the quorum leader or active controller throughout this presentation, but they're basically the same thing. So the quorum leader or the active controller handles the partition assignments, and only the active controller can write to the metadata topics. And then the other controllers are basically followers. They're replicating the metadata topic to their local copy. And if the active controller shuts down or goes away, one of the follower controllers with the most up-to-date metadata gets elected as the new active controller. Okay, so with KRaft, also all of the brokers store the local copy of the metadata topic and communicate with the active controller to keep up with the updates. Brokers are observers of the quorum, meaning that they don't participate in the quorum leader election. They just observe the updates. So as we saw in the previous slide, one of the brokers needed to be designated as a controller in Zookeeper mode. and coordinate the metadata updates with Zookeeper. So now none of the brokers need to do that. It's the actor controller handling all of that instead, and that leaves the broker to handle the client data. Right, so KRaft offers a range of flexibility in how you want to run a cluster. So the first one is dedicated controllers and brokers, which is the recommended setup for production. And this offers better scalability because just as I mentioned, the controllers only handling the metadata data and the brokers handling the client topic data. And this allows you to avoid single point of failure, and it fits much better for large clusters. But you can run the clusters in combined mode as well, meaning some or all of the nodes are serving as both controller and broker. And this simplifies the deployment since you need fewer nodes, and you also get to save some resource in terms of the node count. But note that if the node is serving as both controller and broker, it might potentially need more resources such as memory. And it works great for small clusters for development purpose. You can even run a single node cluster. This is useful if you want to spin up a cluster very quickly just for testing purpose. Okay, so there are a couple of things that will to note when you deploy in KRaft cluster with Strimzi. So in this example, you can see there's a couple of annotations there. So you need to have your node pools annotation enabled, and you also need to have the KRaft annotation enabled as well. And then you will have to create a Kafka node pool resource. And with the Kafka node pool resource, you can specify what role the nodes should be serving as. So in this example, as you can see under the spec, there is a roles field, and you can have one or both of the controller and broker roles. So in this example, you have both of them, so that means the cluster is running in combined mode. For production setup, obviously you would have one Kafka node pool CR for just controllers and then another one for just brokers. Okay, so that was a short intro to KRaft. Now we will look at some metrics. So the metrics I'm going to share now, by no means that is an exhaustive list of the metrics that you have to monitor. These are just key metrics that I could fit into this session, and I think they're quite important in terms of how KRaft clusters work. And hopefully this will give you some good starting point when you start to monitor your KRaft clusters. So we'll first look at KRaft metrics that are specifically for controller quorum and metadata exchanges between them. These are good indication of the quorum health. So the current leader, this is the quorum leader's ID, and this is useful to monitor to make sure that all of the controller nodes are seeing the same quorum leader. And then you have current state, which shows the state of the controller is in. So from high level, we want to see one node reporting as reporting a leader state, and then all the other controller nodes reporting follower state. But there are other states such as observer, candidate, perspective, or unattached. So these are the states that controllers transition into during quorum leader elections. So this could be useful information to monitor, especially if you debug an issue, particularly around election. For example, some reason the quorum leader cannot be elected, or the leader keeps bouncing off between nodes. And then you have current epoch. So all controllers needs to have the same epoch to maintain that consistency and leadership. Otherwise, it could cause leadership conflicts or inconsistent metadata. And a current vote, so this is the ID of the controller that that node is voting for. So this is just useful to see how the quorum leader was elected. Right, so there's a couple more metrics, high watermark and login offset. And this shows these are useful to compare between the follower controllers and the quorum leader to see how far the followers are behind, whether they are keeping up. And then you have election latency, which is either the average or the max time spent on electing a new quorum leader. So higher that latency, potentially the longer the period where you don't have a leader in your cluster. So obviously, if you don't have a quorum leader in your cluster, nothing can write to or read from the metadata. And this could cause various issues with your brokers and clients. But in healthy clusters, this period should be very brief. But if you do see latency increasing, that potentially could lead to problems. And then you have append records rate. This is the average number of records appended by the quorum leader. So the value for this metric coming from the followers will be set to 0 because obviously they're not the one writing to metadata topic, it's only the quorum leader. And then you have fetch records rate, which is the average number of records fetched from the quorum leader. Again, the value coming for this metric coming from the leader itself would be set to 0 because the leader is not fetching from itself. So these two metrics are a good indication of the overall performance in the quorum. So all of these metrics are generally quite good to trend over time, so that you know in your healthy clusters in the normal use case, like how the values usually look like, and so then you can identify if there is any unexpected behavior. Okay, so now we'll look into some controller metrics, particularly for metadata. Particularly for KRaft case. So active controller count is a critical one to monitor, of course, because we always expect it to be equal to 1, no more, nor less. Obviously, this can be 0 during the quorum leader election, but like I said, that shouldn't be that period shouldn't be long. And then you have active broker count. So this is the number of the registered brokers with the KRaft controller and actively working. And then you have fenced broker count, which is so fenced means is the opposite of active broker. So this is the number of registered but fenced brokers. So fencing a broker means a controller is marking that broker as an inactive and prevents it from being elected as a partition leader or being assigned with any new partitions. And broker gets typically fenced if it disconnects from the KRaft controller or it doesn't send the heartbeat request anymore. And once it gets fenced, it can only get unfenced after it can establish connection to the KRaft controller and the active controller and a catch up to the metadata log and start sending the heartbeat request. And then you have the last applied record lag MS. So this is the difference between now and then the timestamp of the last record applied to the metadata topic. And this is a useful one to see how far your controller followers, how long it takes for the follower controllers to get the metadata update. And then you have metadata error count. So this is the number of errors encountered when the controller is processing the metadata log. And it's also good to monitor the metadata related metrics from brokers' perspective as well, because they also store the local copy of, they also have a local copy of the metadata topic, and then it tries to replicate it from the active controller. So offset of the last record applied for the metadata by the broker. So this is useful again to compare with the active controller's log and offset to see how far the broker is and whether it's keeping up. And last applied record lag MS. So this is the same metric I just mentioned for the follower controller. Again, it's how long it takes for the broker to receive the metadata update. And then a couple of error count related metrics. So one is the errors encountered while loading the metadata log, and then the other one is errors encountered while applying the new metadata updates. So those are useful metrics to look at as well. Okay. So there was some screen issue apparently. Was this resolved?
So yeah, there are some people that are not able to see your slide, but anyway, the others can. For example, I'm one of the people able to see your slides. So I was just asking them to refresh. Maybe it's a glitch, it's a problem on their side, not on your side, Tina.
Okay, cool.
So yeah, you can go on. Thank you.
Cool. All right, so next we'll look at rolling updates. So last year's StrimziCon, I gave a detailed talk on how Strimzi operates. Strimzi operator handles rolling updates, including KRaft clusters. So please check it out if you would like to learn more about it. But in this session, I'm going to just cover the key things to know when it comes to KRaft clusters in terms of rolling update. So the first thing to know is the order it takes to roll nodes. So in general, the operator always restarts the unready pods first and make sure they get recovered and start running. And then then only it restarts the ready pods. It also restarts the pod for the controller always at last. So this logic is the same for KRaft clusters as well. But we also now take the KRaft controller, so the KRaft roles into the consideration as well. So for KRaft clusters, we first roll the unready pods like we did before, and then we roll the controller nodes that are followers only, and then the combined nodes that are followers only as well. And then next we roll the active controller. And then we roll the brokers after. So this is the order it goes. The reason we roll all the controller nodes first, because without the quorum, the brokers would not be able to operate. So it's quite important we operate on the quorum first and then make sure it's stable and then go restarts the broker. The operator also does quorum health check before restarting any of the controller nodes, similar to how it does availability check before restarting any of the broker nodes. So to the operator, the quorum is considered healthy when the majority of the controllers are keeping up sufficiently with the active controller. So in this example, I have nodes 0 and 1, which are fallen behind for the metadata topic updates, whereas 2, 3, and 4, they are up to date. So in this situation, only node 0 or 1 can be restarted, since 2, 3, and 4 are up to date, and that makes the majority. However, we cannot restart 2, 3, or 4, because that would take out one of the nodes that makes the majority that are up to date. So that is kind of the overall logic for rolling update. Okay, so we'll now look at migration. So migration from Zookeeper to KRaft requires a lot of manual steps, but Strimzi automates most of this for you. There are just a couple of steps the user would need to interact during the migration, and that gives the user the ability to roll back in case they need to. And the rollback option is basically a safety net in case they want to just practice around the KRaft migration, but not fully migrate yet, or something seriously goes wrong. Hopefully that's not the case. So there are 5 overall migration phases. So the initial phase, that's when we are at the start of the migration where the cluster is still in Zookeeper mode. And then the initial metadata load, and that's when the KRaft controllers comes up and start loading the metadata from the Zookeeper. And then you have hybrid phase and dual write phase. So we'll look into that in the next slides. And then you have the finalized state where the migration gets completed. So to the migration operated by Strimzi operator, it takes various actions. So these are the actions it takes during the migration. So it deploys the controller quorum nodes, and it reconfigures brokers and controllers. So various phases of that migration phases require the nodes to be reconfigured and restarted, so that the operator handles that. And obviously, once the nodes are restarted, they have to wait for it to become ready, make sure the cluster is stable. The operator also keeps track of the migration progress to ensure its completion. So for example, during the migration, if the operator goes away and comes back, it needs to know where it's left off and be able to continue from there. And then once the cluster is migrated, the operator then deprovisions the Zookeeper cluster. So from user side, there are 4 actions that a user needs to take. So the first action is basically just a prerequisite for the migration. As I mentioned previously, they have to create the Kafka node pool resource for the controllers, so the operator can deploy the controllers. And then the action 2 and 3 are the main interactions user has to have with during the migration with the migration process. So one is to trigger the migration using the annotation on the Kafka CR, and then the action 3 is to finalize that migration or choose the rollback if needed. So once the migration is completed, there is just one small post-migration cleanup to do. So when migration is completed, the Zookeeper cluster will be gone. And so the user has to just go and remove the Zookeeper section in their Kafka CR that is no longer needed. Right, so let's try visualize the whole migration process. So we're in the initial phase where you have Zookeeper cluster and your Kafka clusters with broker nodes. So the user creates the controller Kafka node pool. So in this example, I'm creating a quorum with 3 nodes, so replica set to 3. So the general advice is to choose the replica count same as your Zookeeper node. So if you're migrating from 3 Zookeeper nodes, then choose 3. If you're migrating from 5, then choose 5 controller nodes. And then you can see in the roles, I have only controller specified. So, and the user triggers the migration by setting the KRaft annotation to value of migration. So the Strimzi operator has its own states to keep track of the migration progress. So this state is stored in the Kafka CR under the status section, and it transitions through different state values. And we'll see how this state maps to the migration phases we talked about in previous slide. So we first in the initial phase, and then the Strimzi sets the state to KRaft migration. So in this state, the operator will deploy the controllers with the necessary connection details to the Zookeeper, and then the migration flag enabled so that KRaft controllers are aware that they are in migration mode. So as they start up, they will create connection to the Zookeeper cluster. And then in the initial metadata load phase, the operator reconfigures the brokers with connection details to KRaft controllers, and then also the migration flag enabled. So the brokers are also aware they are in migration mode as well. And then it rolls the brokers. As the brokers come up, this is when the migration process starts within Kafka. So when the metadata is loaded, initial migration is completed. We go into this hybrid dual write mode, and then the Strimzi state changes to KRaft dual writing. So what that means is now the controller is handling the metadata updates. The brokers are talking to the active controller of the KRaft quorum, but they are still operating in Zookeeper mode. And the active controller is at this point as seen as the normal designated controller, just like they do in Zookeeper mode. And then the KRaft controller is writing the metadata update to Zookeeper. So that means the metadata gets stored first in KRaft controllers and then gets copied into Zookeeper. So the reason for keeping the Zookeeper updated at this stage is it's important in case the user wants to roll back. Also, the brokers still have the connection to Zookeeper cluster, so that also makes that is also important for the rollback process. So the next phase is the dual write mode, and then the operator reconfigures the brokers to disconnect from the Zookeeper now, and then remove the migration flag. So at this stage, the brokers will come up and they will be running in fully in KRaft mode. But we're still updating the Zookeeper with metadata updates. So that is why we're still in that dual write mode. But the Strimzi state changes to KRaft post migration once the brokers are fully running in KRaft mode. Right, so now is the time for the user to finalize the migration or roll back if they want to. To finalize it, the migration, the KRaft annotation has to be set to enabled. To roll back, they have to set it to rollback. But I will not cover the rollback process in this session because of the time limit. But let's say we finalize in this KRaft migration. The operator will then reconfigure the controllers to remove the Zookeeper connections and remove the migration flag and enroll the controllers. So as the controllers comes up, now the cluster is out of migration mode and is fully running in KRaft mode. And then there is no longer connection between the Zookeeper to the brokers or the controllers. And operator then go and deprovision the Zookeeper cluster. So after the Zookeeper cluster is deprovisioned, if you remember, there's a little extra like post migration cleanup where they can go and remove the Zookeeper section from their Kafka CR. So they can do that now. There you have your KRaft cluster now. So this was a condensed information on migration to KRaft. My colleagues, Kate and Paula, they've given much more detail to talk about this recently in a conference called KRaft. So please check it out. It happened in London a few weeks ago. It was a really good talk. And that was a lot of information. So let's quickly summarize what we just talked about. So KRaft is a distributed metadata quorum where each node is storing the metadata topic locally and keeping it up to date from the active controller. And it's important to monitor the rough metrics as well as the metadata related metrics for both controller and broker. And the operator considers the quorum to be healthy when the majority of the controllers are sufficiently keeping up with the metadata updates, which is crucial for rolling updates. And the migration is automated by Strimzi with just a couple of interactions required from the user for the migration process just to trigger and finalize the migration using annotation. That is it. Thank you very much.
Yeah, thank you, Tina. Yeah, thank you very much, Tina, for your presentation. So let's try to answer. Sorry, maybe this way is better. Let me try to ask some questions that we have here in the Q&A. So the first one is why separating controllers and brokers is better for production? So not running a collocated node or mixed mode.
Yeah, so as I mentioned, so you get much better isolation of the workload, and you get better scalability options. So if your brokers are just handling the client data, you can scale as your load increases without having to worry about your controller nodes. And also, if the brokers, you get the single point of failure. So if that node, if their node goes down, that will impact the quorum as well as your broker availability. So you get that separation of workload and safety for that reason.
Yes, and the next one is when using KRaft mode in a production environment, is it advisable to place one pod per node for the broker or controller?
Sorry. Didn't get the
So
question.
I guess that the question is, if you have a Kubernetes cluster with several nodes, if it's better to place just one pod per each node for running broker and controller. So I guess not collocating more brokers or more controllers or broker and controller on the same Kubernetes node. That's my understanding of the questions.
Yeah, I think that is the recommended setup. Again, that the point I raised about the single point of failure, if your pod goes down, that could potentially bring down multiple Kafka nodes. So yeah, I think the usual setup is one node per pod.
And also, can I use KRaft mode in Strimzi 046 in a production environment?
I believe so. That's when the 4.0 supported.
Yeah, exactly. I will say yes, because anyway, Kafka 4 is production ready, right, in KRaft mode. And this is what we are going to support. So we are actually supporting in 046. Then the next question is, in KRaft, only active controller update metadata. Also, brokers interact with the active controller only, while followers are kind of passive. So how KRaft mode is better than Zookeeper-based setup in scaling?
So, so I guess you get much better performance with KRaft compared to Zookeeper because the updates are within Kafka itself. And then you can scale your controller quorum if you need to, independent from your brokers as well.
Yeah, and also when you are using Zookeeper and you have to rebuild the cache of the metadata, you are reading again from the Zookeeper metadata. So it's a long process, I would say, which is not the same as it happens in KRaft, where you have the Kafka topic replication for you, right? And yeah, I guess there is a follow-up question, but I can't understand to which question was related. Do you mean by pod rule or node? I can't get this from Ryan, so.
I guess that was the one node per pod. So I think that is how you deploy the Strimzi pod set, for example, with Strimzi when you deploy in Kafka cluster. It will deploy the Strimzi pod set, and that will deploy a pod per Kafka node. I don't know if there's any setup we do like running several cluster Kafka nodes within the same pod.
Okay, thanks, Tina. So Ryan, if you need some more, explanation about this, please use the chat where we can have threads and we can continue the discussion or using the Strimzi Slack channel. So maybe we can clarify better if the answer from Tina is fine for you. Thank you, Tina. Thank you very much. Thank you very much for your session.